Okay, on this worksheet, we're looking at applications of counting techniques. So remember, we've covered three counting techniques specifically used for counting large number of lists or large number of items. On this worksheet, we're dealing specifically with permutations and combinations. Now, under each, I have a situation where we would use each. In permutations and combinations, both are used when repeats are not allowed in the counting process. Permutations when order matters, and combinations when order does not matter. Additionally, we have the fundamental counting rule. So these are not three mutually exclusive or separate counting techniques. Sometimes you're going to use the combination rule in conjunction with the fundamental counting rule, or the permutation rule in conjunction with the fundamental counting rule. So permutations and combinations, this is how we count the number of ways to choose groups of items from larger groups of items. The fundamental counting rule is how we break a counting process up into a sequence of individual steps. All right, so let's look at number one. In a class of 18 students, there are 11 men and 7 women. 4 students are randomly picked to present a demonstration on the use of graphing calculators. Okay, so what do we know here? We're picking 4 students, and that's just going to be a group. So it looks like no order, or order doesn't matter here. So no repeats, order doesn't matter. So this sounds like a combination to me. So for part A, in how many ways could we choose all women? So 4 women out of the 7 women. So we're choosing from 7 women. We're picking 4. It's a combination because there's no repeats and order doesn't matter. Now, I'm not going to do the manual calculations here for combinations and permutations. I have an Excel workbook open here where I could just type in the values of N and R, and Excel will give me the values of the permutation and the combination. So let's see. N is 7, R is 4. And so NCR, or 7C4, should be 35. Okay, so now for the second problem, 2 men and 2 women. Okay, we're still choosing 4, but we have our counting process is broken up into 2 steps. We have to choose the men, and then separately we have to choose the women. So the fundamental counting rule says, okay, break this process up, break this counting process up into 2 steps. Count the number of ways each step could be done. So how many ways could we choose the 2 men? Separately, how many ways could we choose the 2 women? And then finally, the total number of groups of 4 should be the product of these 2 numbers, or basically how many ways is each step possible, and then multiply those results. So choosing 2 men out of 11. So that will be 11 combination 2. This is, again, this formula tells us how many ways can we pick groups of 2 out of a group of 11 if no repeats and order doesn't matter. So I'll come back over here to Excel. Let's change this to 11 combination 2. Okay, so that looks like 55. And then 2 women out of 7. So 7 combination 2. Back to Excel. We'll change the N from 11 to 7. So 55 and 21. Hopefully you're seeing the benefit of using Excel for these repetitive calculations, or anytime we're doing the same thing over and over. So we get 55 for the first step in the sequence, and what was it? 21. 21 for the second step in the sequence. 55 times 21, and we could use Excel for calculations too. Let's say equal 55 times 21, 1,155. Okay, so 35 for part A, 1155 for part B.